she separates the sand from a salt solution. Which method of separation she can use? She can use a filtration by passing the mixture through a filter paper. Sand will left on the filter paper and the salt solution will pass through. The student then uses this apparatus to obtain a pure water, as I mentioned. Um Name the pieces of apparatus, label as X, Y, and Z. So X is a thermometer, Y is a Liebig condenser, and Z is a beaker. So thermometer, condenser, and beaker. State what remain in the flask when the separation is complete. When we remove all of the liquid, the water, so what we are left with? We are left with salt, which was present originally or dissolved in the water, or it was there originally solution. But now we are left with solid crystals of salt. In a chromatography experiment, a student uses a sample of 3 pure food dyes, blue, red, and yellow. He also uses samples of 4 unknown substances, St, U, and V. Student puts a small drop of each substance on the pencil. The diagram shows the student's chromatogram at the end of the experiment. Which of unknown substances contain only one food dye? So how you can identify? You can simply check with which substance uh, which of the unknown substance contain only one food dye. So there should be one spot. So when you check S, T, U, and V, T is a mixture of two, U is a mixture of three, V is a mixture of two, S is the one which is only one having one dye. That's why A is the right answer. Next part, explain which pure food dyes are in substance V. So in substance V, we'll check the number of the spots. So when you check the number of spot, substance V matches with B and it matches with R. So B and R are the two substances which are present in V. Because they have the same height above the origin. Calculate the RF value of a yellow food dye Y. So how we can find RF value? It's a distance moved by a spot to a distance moved by the solvent front from the origin. So we'll measure this distance, say A, and we measure the distance which rises by the solvent front, and distance moved by spot divided by distance moved by solvent front from origin will get the RF value of yellow. So you have to use a ruler. A hard copy is needed for this to solve this part so that we can accurately measure the length. State how the chromatogram suggests that the yellow food dye is less soluble than the red are. So how you can identify? You can identify the position because spot red rises to greater height or greater distance from origin as compared to spot for yellow. That's why it shows that the one which is more soluble, it rises more with the solvent. The one which is less soluble, it will rise to a shorter distance from the origin. The box gives the name of some metals. Identify a metal from a box that burned with a bright white flame. So the one which burned with a bright white flame, that is magnesium. In the earth, metals are found either in ores or as an uncombined element. Which metal from the box is most likely to be found as uncombined? So it should be the least reactive metal, a metal which is low in reactivity. So when you check this, you will find silver is the least reactive. So it should be silver. And why? Because it is a less reactive or least reactive metal, does not react with all the substances. This is the order of the reactivity: aluminum, iron, lead, and copper. The method used to obtain a metal from its oxide depends on the reactivity. Two possible methods are there: heating the metal with oxide with carbon, or electrolysis. Explain which method should be used to obtain lead. So when you check the position of, in the reactivity series, when you check the position of the carbon, like if I write the full reactivity series, you can learn from sentence: please send cat, monkeys, and zebra in large high cage, make sure, pet slog. So potassium, sodium, calcium, aluminum, magnesium, aluminum, mercury. Please send cat, monkey, and zebra in large. Its lead is there, high cage, make sure, pet locked. So when you check the position of the carbon position is below aluminum, so it can displace iron from its oxide, lead from its oxide, or copper from its oxide. So explain which method should be used to obtain lead from lead to oxide. So we should use carbon, or heating with carbon. Why? Because carbon is more reactive and it can displace the lead from its oxide, and then we have to write equation for lead to oxide PbO reacting with carbon. This will result in a formation of lead plus carbon dioxide. The diagram shows the arrangement of the particle in a pure metal. Metals are often made into alloys to make them harder. Explain why alloys are harder than a pure metal. Draw a diagram to support your answer. Basically what happened, alloys are a mixture of the metals and they have different particle size. The size of the particle is different, so there is more friction between the layers, so layers cannot slide over each other. That's why alloys are much harder than the pure metal. Alcohols contain functional group OH. They give the structural formula of alcohol that contain only one carbon atom, so that is methanol. So for meth, CnH2n plus 1 OH, or we can write using value of N is equals to 1, so it will be CH3 OH. Ethanol C2H5OH is an alcohol that can be obtained from glucose. Name the process that convert glucose into ethanol. That's called fermentation. Explain why this process is carried out in the absence of air at a temperature below 40. So number one, because it's an anaerobic respiration, so in the absence of oxygen it should be done. And the second thing, the why the temperature is below 40, otherwise if temperature is high it will denature the enzyme. The table gives information about some organic substances, compounds in the same homologous series: ethanoic acid, displayed formula, propanoic acid, and then the third one name is. So H means 2 carbon, so we'll draw 2 carbon, and because it's an oic acid, so C double bonded with O and OH, and this will have 3 hydrogen. Propanoic acid, so C3 and H, when we count 1, 2, 3, 4, 5, 6, and O2. And this one 4 carbons, so 4 it should be but, single bond and due to functional group it will be oic acid, so butanoic acid. Name the homologous sheet that contain these compounds. So that is called carboxylic acid. The compound in the table can react with alcohol to form ester. When preparing ester, a small amount of concentrated sulfuric acid is used. State the purpose of the sulfuric acid. So we use this sulfuric acid is used to catalyze this to speed up the reaction. It is act as a catalyst. Draw a displayed formula of ester when propanoic acid react with ethanol. So as a result, the first name of ester is coming from alcohol. So it will be ethanol plus propanoic acid gives the product that is ethyl propanoid and water. So we have to draw only the ester. The reason why I just write the equation so that you can identify the ester. The first name is always from alcohol and the second is from carboxylic. So to draw the ester, first what we draw the functional group. For ester, it is C double bonded with O and O. That's a functional group. Then H means 2 carbon. That's a branch. So the part which is attached directly with oxygen, that is a branch. So it should have 2. And the one which is attached with carbon, C double bonded with O, is the main chain. 1 carbon is already there, so we'll draw 2 more carbon atoms. And in a displayed formula, you should represent all of the bonds present in the structure. Esters have a particular uses that depends on their property. Give an example of a property and use of the ester. So these esters, they have a distinctive smell, and that's why we use them in perfumes. The organic compound butane diene. But means 4 carbon, die means diene means there are 2 bonds of carbon carbon. Double bond are there. 2 carbon carbon double bond is a colorless gas used in manufacture of synthetic rubber or tires. The displayed formulas of butane diene is shown. Why butane diene is described as unsaturated hydrocarbon, or what is the definition of unsaturated hydrocarbon? So unsaturated means it contains carbon-carbon double bond, and the term hydrocarbon means, the term unsaturated means there's a carbon double bonded with carbon, and the term hydrocarbon means it contains carbon and hydrogen only. Butane diene react with bromine water. State the color chain that occur during the reaction. So when you have bromine water, means it's aqueous bromine, so it should be from orange to colorless. If it is only bromine, then it will be from brown to colorless. The equation for the reaction between butadiene and bromine can be shown using a displayed formula. The table is showing the bond energies. Using the bond energy, we have to calculate the enthalpy chain. So basically, the bond breaking minus bond forming gives us energy chain. So the bond which we are breaking C double bonded with C bonds. How many of them? Two. We are breaking CH bonds 1, 2, 3, 4, 5, and 6. So 6 CH bonds are there. And we are breaking CC bond as well. Carbon-carbon bond, only one. And two bromine molecules. So we are breaking bromine-bromine bonds, and how many of them? Two of them. That will give us the bond breaking. So this will be 2 multiplied by carbon-carbon 612 plus 6 times CH bond energy 412 plus CC bond is 348 plus twice of bromine 193. This will give us the bond breaking. I will calculate that. And what about bond forming? The product side is a bond forming side. So you have 1, 2, and 3 CH bonds, 3 CC bonds, not CH. Then 1, 2, 3, 4, 5, 6 CH bonds are there. And 1, 2, 3, 4 CBr bonds are there. So for CC bonds, carbon-carbon bond, it's 348. For 6 CH bonds, that is 6 multiplied by 412. And for CBr bond, that is 276. And the energy change for any reaction, that's bond breaking minus bond forming. So bond breaking energy, that will come out 4620. Bond forming energy, that will come out 4430. So we want to calculate energy change. When we calculate the bond breaking energy, because it is 2 into 612, 6 into 412 plus 4, and then 348 is there. So this is 4430, and the other one is 4620. So bond breaking minus bond forming is equals to energy change. So 4430 minus 4620. So when we solve, it will come out minus 190 kilojoule per mole. So it shows that for this reaction or forward reaction is exothermic. A scientist does an investigation to find out if butadiene would be a good fuel. He burns a sample of butadiene and observes that carbon formed as a black soot. Complete the equation to explain the scientist's observation. So we have to balance this equation. So whenever you try to balance a combustion equation, start with carbon followed by hydrogen and at the last oxygen. So we have 8 hydrogen, 4 and 2 6, so we need only 2 to balance this carbon number. And what about hydrogen? 6 multiplied by 2, 12. So we need 12. 2 are already there, so 6 multiplied by 2, that will make it 12 hydrogen. Explain how one of the product rather than other than the carbon may cause a problem. Carbon monoxide is a toxic gas. It can cause suffocation. So CO is there, which is also released in this process, which is toxic, can cause suffocation. The equation for the combustion reaction in excess of oxygen is shown. Enthalpy change is minus 3446. Complete the energy profile diagram and label delta H and activation energy. As the reaction is exothermic, so on x-axis, if I take time, reaction progress, exothermic reactions, reactant have more energy and the product is having less energy. And what is our product here? 8 carbon dioxide molecules and 6 water molecules. So 8 carbon dioxide molecules and 6 water molecules. The minimum possible energy at which the reaction start, that's called activation energy. So this level will be activation. And the energy difference between the reactant and product, that is the enthalpy change, which is minus 3446 kilojoule per minute. Question 6. A student is provided with a bottle containing a colorless solution X. Solution X is thought to be a dilute sulfuric acid of concentration 0.1. Student does some experiment on the sample of X to try show that it is dilute sulfuric acid. The student add a few drops of litmus on solution X. The litmus turned red, so it shows that it's an acidic solution. A student notes that the product of electrolysis of dilute sulfuric acid are hydrogen and oxygen. She carried out electrolysis using the apparatus as shown. Suggests why the student does not use zinc electrode. So why in her experiment, why she is not using a zinc electrode? Because zinc is more reactive metal. So zinc will react with sulfuric acid. She states what is observed at both anode and cathode during electrolysis. So whenever a gas is given off, what we will see? We will see bubbles. And both hydrogen and oxygen are colorless, so we will only see bubbles. Which of the tests show that the gas formed at cathode is hydrogen? For hydrogen, when we take a lighted splint, it will pop. So B is the right answer. Describe a test to show that solution X contains sulfate ion. For test for sulfate ion, add acid followed by, acid is already there, so followed by barium nitrate, and observation will be white PPT, which is due to barium sulfate. The student then does a titration to see if the concentration of dilute sulfuric acid is 0.1. She measured 25 cm cube of potassium hydroxide in a conical flask, add few drops of indicator, name a piece of apparatus that she should use as she want to measure exactly 25 cm cube, so she can use a pipette. The concentration of potassium hydroxide solution is 0.125. The volume is 25 cm cube, so we can find the moles. So moles is, concentration is moles by volume, so moles are equal to concentration into volume. 0.125 multiplied by volume, which is 25 cm cube, divided by 1000, because the volume should be in decimeter cube. So it will be 3.125 into 10 power minus 3. Then we have the moles of potassium hydroxide. We can find first the moles of sulfuric acid, as we know, because we need volume of sulfuric acid that is reacted. So 0.1 mole concentration is there. We have already in the previous part, we calculated the moles free point, 125 into 10 to the power minus 3. These are the moles of potassium hydroxide. So using these moles, we can use a ratio first to get the moles of sulfuric acid. The ratio between them is 1 is to 2. The mole ratio, H2SO4 and potassium hydroxide, mole ratio is 1 is to 2. So X, this will be 3.125 into 10 to the power minus 3. So X will be equal to 3.125 into 10 to the power minus 3 divided by 2. We'll get the moles of sulfuric acid. And using the moles, this will be equal to 1.56 into 10 to the power minus 3. And then using we have concentration is equals to moles by volume. So volume is moles divided by concentration. So we have the moles, which is 1.56 into 10 to the power minus 3. The volume, the concentration, that is zero point 0.1. And then the final answer is in cm cube. So what we have to do to convert this final answer, it will be in dm cube, decimeter cube, but we have to convert it to cm cube. So we'll multiply by 1000, so which is equals to 15.6 centimeter cube as the final answer is given in cm cube. This question is about the reaction involving gases. Potassium carbonate react with dilute hydrochloric acid to produce carbon dioxide. The equation is shown. Calculate the volume in cm cube of carbon dioxide produced by 6.9 gram of potassium carbonate react with excess of hydrochloric acid. So first we'll get the moles of potassium carbonate. As we know, moles equal mass in gram divided by molar mass. So mass in gram is given 6.9 and the molar mass of potassium carbonate is given 138. So after getting these moles, that's 0.05. Then we'll take a mole ratio between the potassium carbonate and carbon dioxide. So when you check the equation, the mole ratio is 1 is to 1. So it means if mole ratio is 1 is to 1, if 0.05 moles, then X moles will be there. Same number of moles of carbon dioxide we will get. To get the volume of a gas in decimeter cube, that is moles multiplied by 24. So we have the moles, which are 0.05 multiplied by 24. What we'll get the answer in dm cube, which is 1.2 decimeter cube, but we have to convert it into cm cube. We'll multiply by 1000, which is 1200 centimeter cube. This reaction involving gases is in dynamic equilibrium at temperature 225. Predict the effect on a yield of carbon monoxide at equilibrium when temperature is increased without changing the pressure. The forward reaction is endothermic. So if the forward reaction is endothermic, the reactant have low energy and the product is having high energy. Increase in temperature, shift the equilibrium towards right hand side. So what will happen? The yield will increase. Predict the effect on the yield of carbon monoxide when pressure is increased. So increase in pressure shift the equilibrium towards side where number of moles of gas are less. But in this one you have 2 moles of gas in the reactant and product. So pressure is having no effect on yield of CO because equal number of moles. So if we have equal number of moles, pressure